Assalamu alaikum and hello everyone. This is Dr. Bilal again with another lecture on Introduction to Programming using C++ a step-by-step approach. In this lecture, we're going to get the concepts of variables and data types. We're going to understand that how data type can actually change the memory allocation. What is the relationship of a data type and a variable with a memory, and how the variable can actually store a variable amount of the data. So initially, we'll start off with the definition of the variable and the data type. So variable is a container which can store the specific type of the data and is liable to change. So over here, we can actually, we need to focus on the container and store specific type of data liable to change, whereas the data type defines what type of data can be stored in the variable. So if we actually correlate both of these, this actually is saying that we need to have a container which can store a specific type of the data or specific type of the data, right? And is liable to change. So this means this specific type is based upon the data type. And based upon this data type, if, for example, if we have a certain type of the data that we need to store in a variable, right? So that may actually contain that type of value of that particular data type, right? So let's assume that we have different containers. So because we have a container over here, so let's take this analogy. We have different containers, and these containers, they actually may store different types of data. So if we actually see that these containers can store the water, this container can store gas, and this container can store the chemical. So over here, this water, gas, and chemical, these actually become the different types of the data, right? Which are being stored in different containers over here. So if these are the containers and we consider them as the variables, this water, gas, and chemical, these are the different types of the data that we can actually store in these variables. Okay, right? So over here, the variable, we can call it as a container, and your data type is the type of the material being stored within that container. For example, this water, gas, and chemical. Now, moving onwards, the data type is dependent on, the data type actually determines that what is the size of the volume. For example, if we actually see another analogy, now if we can see this, these are the different gas containers, and these gas containers are of different sizes. They can actually have different volumes of gas which can be stored within this container. For example, over here it starts with a 3.7 kg and it ends with the 210 kg, right? Because it is having different sizes, and these containers can actually store different sizes of the data, this actually is dependent upon the data type. So if the data type is changed, then the size also changes over the with respect to the data type. Considering it as purely a programming aspect, the data that you can store within a variable starts from 1 byte, and it can go up till 8 bytes depending upon the different data types. For example, this Boolean over here, which is considered to be a bool, actually takes 1 byte. 1 byte of the memory. Similarly, unsigned character takes 1 byte of the memory. Character signed, 1 byte of the memory. Then W character, 2 bytes. Short, 2 bytes. Unsigned short, 2 bytes. Integer, 4 bytes. Unsigned integer, 4 bytes. And long, 4 bytes. Unsigned long, 4 bytes. Float, 4 bytes, and so on and so forth. This actually takes up till 8 bytes. So if we actually look at because we in the beginning, as we said, that we're going to see the relationship and understand the relationship between the data type and the memory which can get allocated. So if we are going to define a variable that is of the type integer, then keep in mind that it is going to, one variable of integer type is going to occupy 4 bytes of memory within 4 bytes of memory, right? And the range of the memory, let's actually understand this table as well. The keywords, these are the data types. If we actually look at the keywords, these are the name of the data types. These are the memory allocations, which is the size of the byte. And this is the interpretation. By signed or unsigned actually means that if we purely actually see this, that unsigned means that there is no negative sign with it. It's 0 to 255. The signed means that it has a negative sign and it goes from a negative sign to the positive sign. Similarly, over here, if we actually see as a sign, it goes from a negative to the positive range. Unsigned, from a 0 to the positive. It does not have a negative, right? Signed, again, from a negative to the positive range, right? So signed and unsigned actually means that it is going to start from a negative range and it is going to go towards the positive range, whereas unsigned actually means from a 0 to the positive. It does not include any of the values which are there in the negative. So let's assume if I'm going to have an integer type, right? And this integer type is, for example, signed. Right, let me rub it off and write it again. If we are going to have a signed integer, or we normally call it as an integer, int, right? And I'm going to define it as an x. So this actually means that I am going to store whatever value that we are going to store within this variable x is from a 0 to onwards the positive range, whatever it is, right? From a negative range, sorry. It's negative. From a -2 raised to power 31, I believe this is the one, 31, right? 2 raised to power 30, 1 minus 1. Right, or 2 raised to power 30, right? So this is the range that in which I'm going to store the value. Similarly, if it is unsigned integer type and I'm storing it in x, it is going to range from a 0 to 2 raised to power 31 minus 1. Okay, right? So this is going to actually, this unsigned means there is no involvement of any of the negative numbers, and signed means that there is an involvement of the negative numbers. So this data type actually determines that what type of the data are we going to store, whether, now, for example, if it's a float includes and double includes the both of them includes the decimal numbers. Okay, so if, however, this float has a shorter range as compared to the double, it has a larger range. Okay, and for the shorter range, I mean to say that it actually occupies around 4 bytes, and the range through which I can store the value between unsigned float and, for example, if we can actually see somewhere unsigned int, and I hope there is a float over here. There is a float over here, but I'm not sure this is the right. Okay, this 3.4 into 10 raised to power minus 38 and 3.4 into 10 raised to power 38, both positive and the negative. Okay, so this actually gives you the range of 3.4, whereas if you look at the double, it is more than that. Look at this, 1.7 into 10 raised to power minus 308. So it gives you a very, very large range through which you can actually store the value, whereas over here, the range is not that large. Okay, so I hope that actually makes sense. That is why your double is of a larger range and carries, it actually takes up to 8 bytes within the memory. So I hope this is understandable. And this table is, this table actually makes sense with you that uh, what type of data or what type of data types are there and or their memory allocations, how much bytes do they take within a memory, and then their interpretation and possible values that they can be stored within the variables. So there are certain rules to define the variables. For example, a variable's name can consist of capital letters from A to Z, lowercase letters A to Z, digits 0 to 9, and the underscore characters. The first character must be a letter or underscore. Blank spaces cannot be used in the variables. Special characters like hash and dollar are not allowed. C++ keywords cannot be used as variable names. For example, the keyword get ch, maybe there is a cause, tan. These cannot be actually used as the variable names. IOStream cannot be used as a variable name, and so on and so forth. Variable names are case sensitive. A variable name can consist of 31 characters only if we declare a variable more than one character compiler, with which will ignore after 31 characters. Variable type can be bool, char. Char is basically a character, int, float, double, void, and wchar underscore t. So these are the basic rules based on which the variables are defined. And some of the examples of the variables are like integer. We define int, and then we say num1 total underscore 2 max is equal to 62. So we are assigning the value over here to max, and over here we are actually assigning a simple total underscore 2, and over here a num1 as a variable. Over here, these are the character variables that we are defining. And in, for example, initial underscore letter underscore 32, last underscore letter, middle letter equals to a. So this a, whenever it is an assignment operator, we are going to assign this a to middle letter. And then there is a float variable, sgpa, cgpa, temp class. So these are the float variables that we are defining over here. And then there is a double decimal number, which is a decimal underscore num, where 652.54 is being assigned over here to decimal underscore num. So these are some of the examples of the definitions of the variables, and this is how we actually define the variables. Remember that these variables are case sensitive. Okay, so the case sensitivity actually means that whenever you define any of the variables, you will always access the variable the same way. For example, if you're defining a num1 over here, okay, you cannot say on the later stages as num1, right? Because this is, if this case is capital, it is, the C++ is not going to recognize this num1. It is only going to recognize num1 as the variable, because this num1 is actually defined over here, right? Or maybe if you on the later stages say total underscore 2, it is not going to identify this total, because this is all in caps, right? It is only going to identify this type of a variable where it's starting with the small letter, all the letters are small, and underscore 2, right? So this is a case sensitive language, and it is very sensitive to, for example, if you have defined CGPA, it is not going to identify CGPA, okay, right? And if it is a SGPA, it is not going to identify SGPA. It is going to remain, if you have to access this variable, it is going to remain in the smalls, not in the caps. So that's what a case sensitivity is. So I hope this is understandable so far. So let's see one of the last things in this memory allocation. So if we actually see num1, so we had actually defined num1 over here, integer, that actually means 4 bytes. Okay, this actually means 4 bytes. Char actually means 1 byte. Float actually means 4 bytes. And double actually means 8 bytes. So you can actually see this table to understand that how many bytes each data type is taking. Okay. So following this, if we are defining num1, which actually means that num1 is an int type, which is like 4 bytes. So this num1 is actually going to consider 4 bytes. This is going to take 4 bytes of the memory. Let's assume that this block is a memory. Okay, so if this is a memory, this memory would actually occupy 4 bytes of num1, right? As soon as you initialize this variable int num1, it is going to occupy 4 bytes within the memory. And this number over here, because we are not assigning anything to num1, whenever this num1 is going to be created and whenever this num1 is going to get stored in the memory and whenever this num1 is going to occupy the memory, it is going to have a garbage value. Always remember that. For example, int max, right? We had assigned this 62 to max. Okay, so max is again an int type, which is going to occupy 4 bytes. But over here, what we're doing is we are assigning this max a 62. So instead of having the garbage value, it is going to actually have a 62 within the memory occupied over here. So it also occupies 4 bytes of memory. And over here, because we had already assigned the 62 to max, it actually has a value of 62 with that. And over here, character, middle letter A, it occupies 1 byte. And because we had assigned a letter A to it, right? So this is going to actually store A over here. Similarly, float CGPA, float, this should be a small f. Float CGPA, because it did not actually have anything assigned to it. If we actually CGPA had nothing over here. So it's a garbage value, right? And it occupies 4 bytes. Similarly, double, this is the 8-byte block. And because we had actually stored a 652.54 in this decimal underscore num, we get a 654.54. Similarly, this float temp underscore class did not have anything assigned to it. It's a garbage value, and it actually is occupying 4 bytes of them. So I hope this is understandable now, that how does a variable and the different data types, occupy the memory, and how data type is related to the memory, as the different data types have a different number of bytes which actually are occupied. So I hope this actually makes sense, that whenever we assign the memory, whenever we define a variable of a certain data type, it actually occupies a certain amount of the memory within your memory allocation. And always remember that this memory is actually always have an address. Okay, so we're going to actually see when we are going to compile this thing as well. For example, if num1 is being stored at a certain location within the memory, that memory would always have an address. Okay, similarly, max would always have an address. this would also have an address, a different address. This would also going to have a different address. This is also going to have a different address. So every variable of a different data type, which is being stored in a memory, would actually be having their own addresses. So keep this thing in mind. So I hope this makes the variables and the data types clear. So if you have any questions, you can email me, and you can go to my website and look out for my email address from there, or the point of contact, and you can contact me and ask me questions. Thank you very much.